Okay, so I've gone ahead and typed in the polynomial we just wrote into my calculator. Now I've switched the order around a little bit, doesn't really matter. As long as you got 16 minus 2x, don't do 2x minus 16, that's not the same thing. But I've got all three pieces, the height, the width, and the length typed in, and all of them are being multiplied together. So we need to find the maximum height of this, or the local maximum of this polynomial. So I don't want to just use my standard window. Let's go ahead and adjust our window. Now, one thing I really like is I love when I can make a perfect window. And so x is the amount of space I cut out, the length of that square I cut out. So let's use 0, because I could choose to not cut anything out, although I wouldn't really have a box then. It wouldn't be volume. The most I can cut out, think about it like this. Find your shorter side, 16. And what's the most you could cut out from either end before there wouldn't be a box anymore? Some people say 16, but that's not right, because I can't cut 16 that way and 16 that way. The most I could cut out from either end is just going to be 8. Now, it's not necessary to have that number be perfect, but like I said, I like having a perfect window. I mean, why not? So if I cut 8 and 8, that's the most I could cut out before I started overlapping. Obviously, if I cut 8 inches out, there wouldn't be a box either, because there'd be nothing left over there. All right, so for your y then, your y represents the volume. The minimum volume is 0. That would be if I didn't cut anything, or if I cut 8 out, I'd have no volume. As far as the max volume goes, I really have no idea. I mean, I've already done the problem, as you can see, and I've made a sketch. So I'm just going to guess at my volume. My highest volume. Now, if it's too low, like if I don't see the maximum, if I don't see the top of the polynomial, then I'll just make it bigger, or if I guess too big, I'll make it smaller. So this number is a total guess. And if you don't guess right the first time, that's okay. Don't stress it. Just try again. So let's take graph. And here's what I mean by a perfect window. Look at this. It starts out from the origin. It reaches the maximum, and then it kind of fizzles out. And then, boom, it hits there right perfect in the corner. I love when I can get that figured out. So what I want to do, notice it's not a parabola. It's not perfectly symmetrical. It is definitely part of a polynomial. I want to find that maximum value right there. In a couple years, you guys will be able to look back at this problem and use calculus to do that. But for now, let's go ahead and just use our calculator. So second trace, we want to select maximum this time, because we're trying to find a maximum volume. They're going to ask you those same three questions they always do: left bound, right bound, and guess. So move over here to the left and hit enter. Move over to the right of that high point somewhere and hit enter. And then finally hit enter for guess. And it should find your maximum value. So your coordinates are about 2.94. Let's round to 2 decimal places. And 420.11. Before you finish the problem, though, make sure you interpret what those mean. Don't just list me the coordinates. Interpret what it means and answer the questions. So they say, what should you cut out of each corner? Well, that's x. You should cut out a square that's 2.94 inches long on either side. And then what would the maximum value be? That's your y value. The biggest this box could be, the best cut, would be to cut out that much and get a volume of 420.11 cubic inches.